why the periodic table, why the elements are organized in this structure. Why is good that organization? Why for engineers like you and me keep the elements organized in this table is excellent, is nice, because it's easy to see. Why? Yes, because in this table I know the level of energy of each element. You remember the element located here, 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 they have less electronegativity, and the element located here, 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 in that corner, more electronegativity, more energy, because they have in the last orbit more electrons spinning, no? How many electrons have in the last orbit those elements? 7, 6, 5, 4, 3, 2, and 1. Those elements, they have low level of energy. Okay, this is very important, because when I have two dissimilar metals together, one with the other one, the more noble, the more electronegativity attack the less noble. This is why it's important for me. Let me check. I am going to put together copper and iron. Copper is here and iron is here. Probably iron have less electronegativity than copper. Copper will attack the iron. Yeah. The less noble metal always release the electron and will be eroded. And the more noble attract and will be the cathode. That's clear? This is why this organization is good. Other important thing in this organization is this small division. You remember what happened here and what happened here after the division? Up is and below the division is metals here and non-metals over there. Non-metals are isolators, no metallic, non-metal, and all of those are metals. Nice, no? All of those are metals except one. Which one? This one should be located here because the green color, you know, but it's here because the structure in the last orbit only have one electron. This is why it's located here with other metals. Hey, my friends, lithium, sodium, potassium, rubidium, cesium, francium, they have one electron in the last orbit. They are metals. Beryllium, magnesium, calcium is another metal. Hey, my friend, you need eat calcium because your bones. Calcium is a metal. Those are metals. Alkali metals. Alkali solutions. Those metals. What happened with those metals? What is the inconvenience of those metals? They react with water, no? Except magnesium. Magnesium no react with water. Magnesium is stable. It's more stable. Oh, nice, incredible. But the other one, the alkali metal, they have that inconvenience. Other important thing is in this organization is those rows. What is the meaning of this? What is the meaning of this one? They have only one orbit, and those 2 orbits, 3 orbits, 4 orbits. No? Remember that in the atom, the amount of electrons spinning are equal to the amount of protons in the nucleus. And listen to me, in the nucleus you have protons and neutrons. The neutrons are neutrals. The neutrons only added weight. If I have more protons in the nucleus, also I have a lot of neutrons, and probably that element is too heavy. This is why the heavy metals are located in the bottom, because they have a lot of orbits. For example, lead is too heavy. What about lithium? Lithium is heavy?
No.
Lithium is too
Super
light.
light.
It's only 2 orbits. What about aluminum? Aluminum is heavy? No, aluminum is 3 orbits. Probably 3 electrons in the last orbit and probably 3 neutrons. How many neutrons left? More, because it's in the bottom, more orbits. You understand, guys?
Gold.
Gold, 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 copper, silver, and gold. Gold is heavy. Gold is heavy. Look at this group. Copper, silver, and gold. They are organized in a triad. They have a similar structure, pretty close structure. Gold, silver, and copper. They are precious metals. Wonderful, no, guys? What is the name of those metals here?
Ferrous.
Transition metals.
Transition metals.
Transition metals. And here in that group, in the blue ones, are located the most common metals used in different alloys, in different applications. Here you know nickel, copper, zinc, magnesium, chromium, vanadium, molybdenum. All the metals that you have in special alloys are located over there. And except this one, how many electrons they have in the last orbit?
3.
3. And what about this one?
4.
How many electrons in the last
2.
orbit? 2. 2. Look at this. Zinc, cadmium, and mercury. They have 2 electrons in the last orbit.